Hello students, in this video we are going to learn about the process called resonance. What is this phenomena called resonance? In order to understand that, we'll first take ozone molecule. You know, ozone is made up of O3. That is, it can be considered as a combination of O2 plus O. You have learned how to draw the Lewis structure for oxygen molecule. Oxygen has atomic number 8 and so it has a valency of 2. That is, only 6 electrons are present in the outermost shell, out of which it is sharing the 2 electrons with the other oxygen atom, leading to a double bonded structure. As a result, you find 2 pairs of electrons are there on the second oxygen too. Now, we'll see what happens to the structure of O2 molecule when another oxygen atom comes nearby. This oxygen has 6 electrons. So you find that there should be a link formed between the second oxygen and the third oxygen. With the result, you find that the linkage is formed by a coordinate bond or dative bonding. With the result, you find that the structure will be assuming an angular shape with 2 pairs of electrons on the first oxygen, 2 pairs remaining on the second oxygen, and the third oxygen has 3 pairs of electrons. You find that in order to link it between these two, you find the pair of electrons on the second oxygen is donated to the third one. With the result, you find that it is equivalent to a structure. I'll write on the second line O double bond O. When the coordinate bond is converted to a single bond, you get bond O with 3 pairs of electrons. That is 3 lone pairs on this oxygen. With the result, you find that first oxygen will have 2 lone pairs. Second one will have only 1 lone pair and the third one is having 3 lone pairs. Check the charge on each atom. First oxygen, you find the total number of valence electrons become 1, 2, 3, 4, 5, 6. That means this is neutral. What about the case with the middle oxygen? Here you find that 1, 2, 3, 4, 5. Only 5 electrons are owned by this oxygen. With the result, it has a positive charge because it has donated 1 electron permanently to the third oxygen. So when we check the third oxygen, you find that we have total of 6 electrons around it plus 1, total 7 electrons are there, which gives rise to a negative charge. Now you check the condition here. In this molecule, we find that there is charge separation. In addition to that, we have a condition where we have lone pair is separated from the double bond using a single bond. That is lone pair, single bond, double bond. Such a molecule is highly unstable. So in order to make it stable, we find that the electrons start drifting from the side which has more number of electrons to the side which has less number of electrons. These conditions are prevailing in cases where there is instability in the molecule. So if single Lewis structure is unable to explain the stability of the molecule, we resort to what is called resonance. And what are the conditions for resonance? When the molecule has a condition where we have lone pair, single bond, double bond, or we have alternate double bonds, or we have positive single bond, double bond, the electrons start drifting from the side which has more number of electron density to the side which has less density in electrons. So this process we call it as resonance. So what do you understand by resonance here? In the molecule ozone, if you check here, you find that electron density is concentrated on the rear oxygen. This oxygen is negative. So from this side, electron starts drifting to the other side. When it is shifted, you find that two electron shift happens and it results in a double bond. As soon as it forms the double bond here, the number of electrons present on the middle oxygen increases. So simultaneously, there will be a shift of the electrons, that is the pi electrons get shifted to the next oxygen. With the result, we find that we are getting a structure O, O, O. Here you find that this was the bond that was present earlier. Now it has been converted to a double bond. With the result, the bond length decreases. Now this double bond has been converted to a single bond. Now just distribute the electrons here. You find that the electrons that are remaining will be 1, 2, 3, 4. So total of 6 electrons. That means this oxygen is neutral now. Now coming to the middle oxygen, you find that only 2 electrons were present initially. It is still remaining as 2 electrons. So total number of electrons around this oxygen becomes 1, 2, 3, 4, 5. That means it is carrying a positive charge. Now coming to the last oxygen, here you have 1, 2, 3, 4. It was present earlier itself. Now the shifted electrons has become 2 here. With the result, we have total of 6 plus 1, 7 electrons. So oxygen, it is neutral when it has only 6 electrons. Now it is 1 extra. That means this is carrying a negative charge. Now we can check the structures. First structure is different from the second structure in the position of the double bond, and that means the actual structure on analysis, we find that ozone has a partial double bond character. According to the data available for oxygen atoms, you find that O single bond O is lengthier and it has a bond length of around 148 picometers, and that of O double bond O is 121 picometer. But when we check the structure of ozone, you find that ozone will have oxygen, the bonded oxygens will be of bond length around 128 picometer. That implies that in ozone we don't have a true double bond or a true single bond. So it is lying in between. So how can you explain the structure? So for that we are using the process called resonance. So in the phenomena called resonance, you find that the electron density gets shifted from the side which has more electrons to the side which has relatively less electrons. With the result, you find that more than one structure is possible for ozone, and the actual structure of ozone is lying somewhere in between these structures. That means these two structures are unstable structures or limiting structures, or it is otherwise known as canonical forms or resonating structures. So two different resonating structures will contribute to the actual structure of ozone, and in ozone you find that there is only three oxygen atoms which are arranged angular, and this has a partial double bond character. So this structure we call it as a resonance hybrid. In the process of resonance, you find that when one structure flips to another structure, there is a rearrangement, and we shall now see the resonance structures of nitrogen dioxide, which is the central atom here. Nitrogen dioxide has the formula NO2. Evidently, nitrogen becomes the central atom. You know that nitrogen is having valence electrons 5. Its valency is 3. And so, you find that oxygens will be arranged on either side. So, here we are just drawing the angular structure of nitrogen dioxide. So you find that total of 5 electrons are to be arranged. So here we find that 1, 2, 3, 4, 5. This is how I arrange the electrons on oxygen, on nitrogen. Now arranging the electrons on oxygen, we have 1, 2, 3, 4, 5, 6. So that means it is having a double bond in between. Whereas the next oxygen is also having 6 electrons, and that 6 electrons we are arranging 1, 2, 3, 4, 5, 6. So you find that the second oxygen is having a connection with the nitrogen through a coordinate bond. Now once I convert the coordinate bond into a single covalent bond, here you find that there will be charge separation. So the structure becomes N single bond O. This becomes double bond O. Total number of electrons here become 1, 2, 3, 4, 5, 6. So that means this oxygen is neutral. Now we have an odd electron on nitrogen retained there, and now the charge on nitrogen 1, 2, 3, 4. Only 4 electrons are there. Actually nitrogen should have 5 electrons. That means it is having 1 electron less than that, so it is plus. Whereas oxygen has 1, 2, 3, 4, 5, 6, 7. That means it is 7 electrons. 1 electron is extra, which will give rise to a negative charge on oxygen. Now just check the molecule here. Is there a chance of resonance? What are the conditions for resonance? Either the molecule should contain alternate double bonds, or you should have lone pair single bond double bond, or you have positive single bond double bond. Here you find that it comes to the category lone pair single bond double bond. So here the electrons are concentrated on the oxygen here, and so oxygen donates its electron to the double bond. So it results in a double bond here. It donates the electron to the nearby bond, and with the result there is a simultaneous shift of the pi electrons to the next oxygen. With the result we get the next resonating structure NOO, what happened to the double bond here? It became single bond, and we have 1 2 3 4, and the 2 electrons that are gained, with the result it will gain a negative charge. On nitrogen we have the odd electron, and we have the single bond being converted to a double bond now, and the number of electrons present on the other oxygen becomes 1 2 3 4. And how many electrons are present on the nitrogen atom now? 1 2 3 4. That means it is devoid of one electron. That means it is getting a positive charge. So just check the structures of nitrogen dioxide. In the first case, you find that there was a single bond here. Now it has been converted to a double bond. This has been converted from double bond to single bond. So these two are the contributing structures, or that will be called as the canonical forms of nitrogen dioxide. With the result, nitrogen dioxide will attain somewhat a stability. A stability is attained, and actual structure of nitrogen dioxide will have a resonating structure, or it is a resonance hybrid of two different structures, where it has nitrogen carrying a positive charge. We have oxygen separated now, and we have a bond here that is with partial double bond character. So if we are drawing positive here, then we shall draw negative on one side or the other side, or else you just write it as N double bond O, single bond O. So what do you understand by resonance? According to the concept of resonance, whenever a single Lewis structure is unable to explain the stability of the molecule, you find that a number of contributing structures which are having similar energy, positions of nuclei, and bonding and non-bonding pairs of electrons, they start shifting from one side to the other. And what are the conditions for resonance? You find that whenever we have alternate double bonds, or positive single bond double bond, or lone pair single bond double bond, the process of resonance occurs. The actual structure of the molecule will be a resonance hybrid of all the contributing structures, which are known as the canonical forms or the resonating structures. The energy change that is involved during the shift of electrons from one form to another, that energy we call it as resonance energy. With the result, the molecule attains some stability. You find that nitrogen dioxide is an odd electron species which is very reactive, and it attains some stability due to the process called resonance. I'll just wind up this video by explaining the structure of carbonate ion. What is carbonate ion? Carbonate ion has the formula CO3 2-, which is the central atom here. You find that it is carbon, and around carbon we have 3 oxygens. So I'll arrange 3 oxygens at the corners of an equilateral triangle. You can draw it in any manner. So then you find that to just draw the Lewis structures, we should know how many valence electrons are there on each. Carbon has valency 4. That means it can form 4 covalent bonds. And here you find that I'm just drawing the double bond here, and one bond this side and one bond this side. Total of 4 electrons are used. That means it can form covalency 4. At the same time, how many electrons are present on each oxygen? We'll check. Here you find that oxygen is using 2 electrons of its own, and here we have total of 1 2 3 4, so total 6 electrons. Together it is getting 8 electrons by sharing, so this oxygen atom is neutral as such. Now we have to arrange two oxygens with two negative charges. So we are just distributing negative charges on either oxygens. With the result, we find that it should have total of 7 electrons on each. With the result, you find 1 2 3 4 5 6 7. So that means this is carrying a negative charge, and the next oxygen also is carrying a negative charge, 1 2 3 4 5 6 7. So it is negative. So you find that both these oxygen atoms are having plenty of electrons. So what is the condition for resonance? You find that electrons start drifting from the side which has more electrons to the side which has relatively less electrons. So you find that electrons can jump from this oxygen towards the double bonded oxygen, or it can use up the electrons present on the other oxygen with the negative charge to the double bond. So you can use it in another manner, in either way, and you find that if I just transfer the electrons here, so it is undergoing resonance, it becomes a double bond. As soon as it reaches here, you find the number of electrons on carbon becomes 5. That is not possible. Simultaneous change will be there by shifting the pi electrons towards oxygen. With the result, you find that the next structure that is obtained will be COOO. We have total number of bonds here which will be double bonded. Now this becomes single bonded, the other one becomes single bonded, and we have total of 1 2 3 4, and the 2 electrons that are given from the pi electrons, pi bond will be shifted, and so we have total of 7 electrons, that is negative. Whereas here you find that it is retaining only 2 plus 2 electrons, so total of 6 electrons. This becomes neutral. With the result, you find that the other oxygen is undisturbed, so it will remain as such with a negative charge. So this is the second resonating structure. Coming on to the next resonating structure, instead of doing the resonance from the left side, we can do it from the right side too. So then if the right side oxygen is involved in the resonance, you find that electron shift occurs here. With the result, the electrons on carbon becomes increased, with which the pi electrons get shifted, and then we have the next resonating structure where we have carbon, oxygen, the other oxygen, and the third oxygen. Here we have bond, double bond. This side it became the single bond, and this is already single bond. So we have total of 1 2 3 4 and 2 electrons here, so it is carrying a negative charge. Now this has become 1 2 3 4, the 2 electrons that are shifted from the pi electrons, so it will become negative here, whereas the other oxygen atom becomes 1 2 3 4 5 6, so total 6 electrons, so that means it is neutral. So in carbonate ion, you find that more than two structures are possible. Actually, it is a resonance hybrid of 3 different structures. These are called the resonance hybrid, and you find the actual structure will be, the actual structure is a resonance hybrid of 3 contributing structures or 3 canonical forms, which we represent as equivalent to single bond, single bond, single bond, and it is having partial double bond character everywhere. So it is carrying total of two negative charges. So we needn't specify on which oxygen it is placed. We just have to mention that there are two electrons extra. Hope it is clear. We'll just check the structure of benzene now. Benzene has the formula C6H6, which we will rewrite as, we will write it as a hexagon with alternate double bonds. So here you find that total of 4 bonds are there around each carbon, and it is tetravalent in nature. That is why it is having 4 bonds. And you find that when the electrons are shifted on to one side, the number of electrons here becomes more. With the result, this carbon will try to readjust. So with the result, you find that the pi electrons get shifted the other side. When the pi electrons are shifted here, the carbon here will have more number of electrons. With the result, the pi electrons again get shifted. And in effect, what happens is this structure of benzene is interchanged with a new structure wherein you find the position of the double bonds are shifted. Here you find that in between we had only single bond. Now it has been converted to a double bond. This was earlier a double bond. It has become a single bond. Now this has changed to a double bond. Likewise, this single bond becomes a double bond. So these two structures, they are known as the canonical forms of benzene, which is also known as Kekulé structures of benzene. So the actual structure of benzene is a resonance hybrid of these two Kekulé structures. And so the resonance hybrid is better represented by using a delocalized ring in between. So here you have the structure H, 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 H on each carbon. So you have C6H6, and we find that the electrons are shifting its position from one side to the other. With the result, the pi electrons get delocalized. It is not in the localized form. It is not fixed. The pi electrons are shifting, or we say that the pi electrons get delocalized. With the result, the pi electrons will form a ring current here. So we represent benzene better as C6H6 with a ring inside. This is due to resonance. Suppose we want to find out the charge on an atom. We have a formula for finding out the charge on the atom. Formal charge on the atom is equal to valence electron present on the free atom minus lone pair electrons minus half of bonding pair electrons. Hope it is clear. So by using this formula, one can find out what is the charge in each atom. Take the example of ozone. O, double bond, O, single bond, O. Mark the number of electrons present on each atom. So we have 1, 2, 3, 4. This case we have only one pair, and the next oxygen we have 3 pairs of electrons, but we are not sure what is the charge on each atom. So to find out what is the charge on the atoms, we'll use the formula given above. Identifying each and every atom, I am just numbering it as 1, 2, 3. So now we'll find out the charge on each oxygen. So charge on first oxygen is equal to, what is the valency of the first one? Oxygen, it belongs to group 16. So valence electrons will be 6 minus, how many lone pairs are there? 2 lone pairs. So total number of electrons will be 4. So lone pair electrons become 4 minus half of, how many bonds are there? Here we have 2 bonds. 2 bonds means total of 4 electrons. Half of 4. So then what will be the value? The value becomes 6 minus 4 minus 2, which is equal to 0. That means there is no charge on the first oxygen. Now take what will be the charge on second oxygen, that is the middle oxygen. We'll just check. Which is the element here? It is oxygen. Oxygen's valence electrons are 6. So here you find that how many lone pairs are there? Only one lone pair, that means 2 electrons, minus half of, how many bond pairs? Here we have 1, 2, 3. 3 bond pairs means total of 6 electrons are there. So half of 6. So what will be the net charge? It will be 6 minus 2 minus 3, which is equal to plus 1. So the second oxygen will carry a positive charge. Now, charge on the third oxygen, on oxygen number 3. It is again oxygen, so valency will remain the same. Valence electrons will be 6, valency is 2. We want valence electrons minus lone pairs. How many lone pairs? 3 lone pairs, so total 6 electrons, minus 6 electrons, minus half of bonding pairs of electrons. How many bond pairs are there? Only one bond pair, half of 2. So what will be the net charge here? It is 6 minus 6, that is 0, minus half of 2, that is equal to negative 1. With the result, the last oxygen will carry a negative charge. So in either way, you can find out what is the charge on each and every atom. Hope it is clear. Thank you.